Alright, in this video we're going to be talking about magnetic flux and flux density. Now first, magnetic flux refers to the amount of magnetic field lines penetrating a given cross-sectional area of a surface, and it is usually represented with the symbol phi. Alright, this is a Greek alphabet phi, and you need to know that magnetic flux is measured in Weber. This is the unit of measurement of magnetic flux. Now we'll talk about magnetic flux. All right, basically it is all about the field lines. As you can see in this diagram, it's talking about the magnetic field lines penetrating a given cross-sectional area of a surface. All right, so this is our surface here, and then we have our magnetic field lines penetrating this surface. Now you need to also know that magnetic flux mathematically is equal to the dot product of the magnetic field strength, also known as the flux density, and the cross-sectional area. Magnetic flux is equal to the dot product of magnetic field strength and cross-sectional area, that's B dot A. All right, now from vector dot products, whenever we have B dot A, whenever we have a case like this, B dot A is simply the same as BA cos theta. All right, so magnetic flux is BA cos theta, or you can say B dot A. The whole of this can be simplified to this. So this is our equation for magnetic flux. Now the next one, flux density. Flux density often represented with the symbol B. All right, like I said, this guy here is still flux density. Flux density or magnetic flux density represented with the symbol B describes the strength of the magnetic field. That's why it's also called magnetic field strength. It describes the strength of the magnetic field, and then it talks about the concentration of the uniformly distributed flux per unit area. All right, the concentration of the uniformly distributed flux per unit area. That's why if we make this guy subject of the formula, you can also have that magnetic flux density is equal to magnetic flux all over area. And then flux density or magnetic field strength. All right, don't forget this is also magnetic field strength. It's also called magnetic flux density. Flux density, its unit is Weber per meter square, or you can say Tesla. All right, how did we get the unit? Flux, remember, is measured in Weber, and area is in meter squared. So these together will give us Weber per meter squared. So this is the unit for magnetic flux density. Now you need to understand that 1 Weber per meter squared, all right, is equal to 1 Tesla. So basically they are the same thing. All right, so if you don't use Weber per meter square, you can also use Tesla. Now for a force on a charge introduced into a magnetic field, whenever a charge is introduced into a magnetic field, it experiences a force. Take for instance, we have a charge, in this case a negative charge, introduced into a magnetic field. This is a magnetic field, all right, created between the north pole and the south pole of two different magnets. Okay, so we have a charge introduced into this magnetic field with a velocity. Of course, the charge is going to move into the field with a velocity. Now that charge will experience a force. That's why in this diagram it is illustrated like this. You have the charge, this is the part of the charge introduced into the magnetic field. Now once it gets into the field, you see that it will tilt upwards, or it will start moving upwards. Now this is due to the presence of that force. Okay, so a charge introduced into a magnetic field experiences a force, and the magnitude of that force, or the force, mathematically is given as Q multiplied by the vector cross product of the velocity of the charge and the magnetic field strength. That's why it's written like this. So this is the force. All right, we have the force, we have the charge introduced into the field with a velocity, and then we have the magnetic field strength. This is the magnetic field strength, all right, acting on this part. So now, like I said, the force mathematically experienced by that charge is equal to Q multiplied by the vector cross product of the velocity of the charge, all right, and the magnetic field strength V cross B. Now this can further be simplified to F equals Q. Now from vector V cross B is equal to VB sine theta. All right, so the whole of this will be simplified to VB sine theta. All right, so F is equal to QVB sine theta. This is a very important equation. All right, the force experienced by the charge is equal to QVB sine theta. Now take note, when F is 0, all right, F is 0 when V and B are parallel to each other. Now please don't forget, theta is the angle between V and B. So if V and B are parallel to each other, F will be 0. How did we arrive at that, or how did we know that? From our equation, F equals QVB sine theta. If V and B are parallel to each other, it simply means the angle between them, all right, that's theta, will be 0. So we are going to have VB sine 0. So QVB sine 0 is 0, so the whole of this 0 times QVB, that will give us 0. So the force will be 0. Now however, when V and B are perpendicular to each other, the force is maximum. So the force is said to be maximum when V and B are perpendicular to each other. That's to say the angle between them is 90 degrees. So we're going to have F equals QVB sine 90. As sine 90 is 1 times the whole of this, that will give us QVB. Alright, these points are actually very important, so please take note of them. Now let's look at some practice questions here. Here it says find the magnetic force experienced by an electron projected into a magnetic field of flux density 10 Tesla with a velocity of 5 times 10 raised to the 7 meter per second and in a direction 60 degrees and then parallel to the magnetic field. So you can pause this video and see if you can attempt this question. Now to solve this question, all we need to do here is they say find the magnetic force. So we are looking for the force unknown. Our force is unknown. Find the magnetic force experienced by an electron. All right, an electron. Our charge here is an electron. An electron has a charge of 1.6 times 10 raised to the power of minus 19 coulombs. So this is the magnitude of our charge. All right, by an electron projected into a magnetic field of flux density. Okay, so they gave us the flux density or the magnetic field strength to be 10 Tesla. With a velocity, they give us the velocity to be 5 times 10 to the power of 7 meter per second. And in a direction 60 degrees. So for the first part of the question, our direction theta is 60 degrees. All right, so to solve this, we just use our formula QVB sine theta. So we have F equals QVB sine theta. All right, Q here in this question is 1.6 times 10 raised to the power minus 19. So we have 1.6 times 10 to the power of minus 19 times V, which is 5 times 10 to the power of 7, multiplied by B, which is 10, then multiplied by sine theta, which is sine 60. All right, so at the end of the day, we are going to have F equals, we can use our calculator to simplify this, and then we're going to have that the force that will be experienced by that charge will be 6.93 times 10 raised to the power of minus 11 Newton. Okay, so that is the value of the force. So this is for the first part of the question I. Now for the second part of the question II, it said when and in a direction parallel to the magnetic field, that's we have the velocity being parallel to the magnetic field, we need to calculate the force. Again, the same parameters, so we'll just make reference to our formula F equals QVB sine theta. But in this case now, since they are parallel, all right, since they are parallel to each other, the angle between them will be 0 whenever you have the quantities parallel to each other, the angle is always 0. So we are going to be having sine 0. And sine 0 is 0. So 0 times the whole of this will give us 0. So the answer to this is 0 Newton. So this is the answer to the first part of the question. And then this answer to the second part of the question. Now question 2 here says, the force on a charge traveling in a magnetic field is maximum when charge is, we already answered this here. Alright, F is maximum when the charge V and B are perpendicular to each other. So this question says the force on a charge traveling in a magnetic field is maximum when the charge is moving parallel to the field. Is that correct? No. Moving perpendicular to the field. Exactly. So this is our correct answer. Option B. Alright, moving at 60 degrees, no. Moving at no. So this is our correct answer. Option B to this question. Now question 3 here says, for moving charges, they experience a magnetic force in a magnetic field. Alright, so they are asking you what the force is. Basically, you have the magnetic force, or F, to be Q dot V dot B. This is not correct. That's not the equation I gave to us here in this lesson. Alright, so the second one here is F equals QV dot B. No. And then this is the answer, option C, QV cross B. If you recall, I said it that the force experienced by the charge introduced into a magnetic field is equal to Q, then the vector cross product of the velocity and the magnetic field strength. So this is the answer, option B. Now question 4 here says, alpha particles are accelerated from rests through a potential difference of 1 kilovolts. Then they enter a magnetic field B perpendicular to their direction of motion. They say calculate the radius of their path. All right, this is a very interesting question. All right, so take it bit by bit. We need to calculate the radius of the path, all right, of this alpha particle. Say alpha particles are accelerated from rest through a potential difference of this, and then they enter a magnetic field B, all right, 0.2 Tesla, perpendicular to their direction of motion. Okay, perpendicular to their direction of motion. Calculate the radius of their path. All right, so now we are looking for the radius. What are the parameters they gave to us? They gave us the potential difference, V, to be 1 kilovolts. They gave us the magnetic field strength to be 0.2 Tesla, 20 Tesla. And then they said it's perpendicular to their direction of motion. So we have our angle given to us in this question actually, okay, to be 90 degrees since they are perpendicular to each other. Now they are asking us for the radius of the path. Now they also give us the mass of alpha particle, Ma. So the mass of alpha particle is 6.68 times 10 to the power of minus 27 kilograms. And then they gave us the charge on each alpha particle to be plus 2 electron. All right, and don't forget the charge on one electron is 1.6 times 10 to the power minus 19. So this will be equal to 2 times 1.6 times 10 to the power of minus 19. And this is equal to 3.2 times 10 to the power of minus 19 coulombs. All right, so this is the charge here. So how do we go about this question? We're looking for the radius here. All right, to get the radius we need to make reference to, because they said calculate the radius of their path. All right, calculating the radius of their path simply implies that, but the fact that they mentioned radius here simply means the path is actually a circular path. Alpha particles are accelerated from rest through a potential difference of this. They then enter a magnetic field, all right, perpendicular to their direction. Calculate the radius of the path. So that's to say the alpha particles will now move in a circular, actually moving in a circular manner, all right, for us to be asked the radius. And the force experienced, all right, in a circle, or that keeps an object moving in a circular manner, is what we call the centripetal force. All right, so we need to make reference to this equation. Centripetal force equals mv squared over r. This is our equation. This is the main equation we are going to use to solve this question. They're asking us for the radius, a circular path, and the force experienced in a circular path is this, the centripetal force, which is mv squared over r. All right, you need a prior knowledge of mechanics in order to come up with this. All right, working with what they gave to us from this equation, remember what is going to make this alpha particle to now move in a circular path is the force experienced by the magnetic field. All right, we have the alpha particles being fired into a magnetic field. Because of the magnetic field, they will move in a circular manner. All right, let me explain what I mean here. They will move in a circular manner. There will be a force dragging them to the center, the centripetal force, and then what causes them to now move in that circular manner is actually the magnetic force. We can write it as Fm. Now, on entering the magnetic field, they will experience a force which is the magnetic force, and then that will cause them to move in a circular path. All right, so to continue moving in this circular path, these two forces must be in equilibrium. All right, so now we also have our magnetic force F, or we can just call it F instead of Fm. F will be equal to, let's just leave it as Fm. Fm will be equal to QVB sine theta. All right, now remember these two forces, like I said, must be in equilibrium. So we have centripetal force equals the magnetic force. So centripetal force is mv squared all over r equals F magnetic force, which is QVB sine theta. All right, now this v here is velocity, and here is also velocity appearing on both sides. So the whole of this will cancel just one of this. So we're going to arrive at mv all over r equals qb sine theta. So now you're going to discover that m was given, which is the mass of the alpha particle. V is the velocity, all right, with which the alpha particles will move into the magnetic field. This was not given. All right, we're looking for the radius. The charge was given. All right, we know the charge, and then we know the angle theta. Magnetic field strength was also given, but then V is unknown. So how do we calculate V? All right, it is very easy. Now to get V, we need to understand something, that an alpha particle, or a particle, all right, that moves through a potential difference V, okay, will have an energy to be QV, all right, equals half mv squared. All right, I'll take that again. A particle fired, or a particle that moves through a potential difference of V, all right, a particle that moves with a potential difference of V will have an energy given as, or mathematically represented as, QV equals half mv squared, where this big V is the potential difference and then this small v is the velocity with which the particle will move. All right, so in this case we have an alpha particle, so our charge is 3.2 times 10 raised to the power minus 19. Mass of alpha particle is also given. We need to get the velocity. All right, so that is what we want to solve here. So now Q was given, potential difference was given, which is 1 kilovolt, which is equivalent to 1000 volts. We need to convert this to 1000 volts. All right, so substituting our values here, we're going to have Q being 3.2 times 10 raised to the power minus 19. That's the particle that was fired. All right, times 10 raised to the power minus 19. Okay, multiplied by the potential difference of 1000 volts equals 1 over 2 times the mass of the alpha particle, which is 6.68, 6.68 times 10 to the power of minus 27. Okay, then multiplied by the square of the velocity, which is what we are looking for. So if we simplify our left hand side, we're going to get 3.2 times 10 to the power of minus 16. Okay, equals, simplifying your right hand side, we'll have 6.68 times 10 raised to the power of minus 27, right, multiplied by 0.5. That will give us 3.34 times 10 raised to the power of minus 27 v squared. Alright, so to get this, to get v, you divide both sides by this. So we're going to have 3.2 times 10 to the power of minus 16 divided by 3.34 times 10 raised to the power of minus 27 equals 3.34 times 10 raised to the power of times 10 raised to the power of minus 27 v squared all over 3.34 times 10 to the power of minus 27. So the whole of this will cancel this. Then we'll be left with v squared equals 9.58 times 10 raised to the power 10. But what we need is v. So to remove this squared, we'll take square root of both sides. Alright, so that will give us v squared, square root of v squared equals square root of 9.58 times 10 raised to the power 10. Alright, so this will cancel out this, so we have just v, alright, which is the velocity. Alright, don't forget we had two v's here. This was big V, uppercase letter, potential difference, and small letter here, velocity. Alright, so square root of the whole of this, and that will give us 3.095 times 10 raised to the power 5 meter per second. So that's the velocity we are going to be using for this question. So at this point, I think all our parameters are in place now. All right, we have the mass given, mass of the alpha particle, the velocity, the radius, the charge, the magnetic field strength, and we have the mass given to be 6.68 times 10 raised to the power minus 57, the velocity to be this, the radius, which is what we are looking for, the charge, which is 3.2 times 10 raised to the power minus 19, the magnetic field strength, which is 0.2 Tesla, and then theta, which is the angle, 90 degrees, because they are perpendicular to each other. Alright, so now we can proceed to finish up our question. So recall, this is the equation we're going to be using to solve. And how did we arrive at this equation? It's from here. Centripetal force is equal to the magnetic force. So write it down here again. mv, which is the velocity, alright, which is what we've just found now, all over the radius equals QB sine theta. Alright, so m again, which is the mass of alpha particle, that will give us 6.68 times 10 raised to the power of minus 27 times v, which is what we have here, 3.095, okay, times 10 raised to the power 5 all over the radius, okay, which is equal to, can take out this, all over the radius equals q, which is 3.2 times 10 to the power minus 19, 3.2 times 10 to the power of minus 19 times the magnetic field strength, which is 0.2, all right, multiplied by sine 90. All right, so at the end of the day, our numerator, this will give us this will give us 2.067, rather 2.068 times 10 to the power of minus 21 all over r equals, on the right hand side we're going to have 6.4 times 10 raised to the power of minus 20. So to get r here, we can cross multiply. This is simply this all over 1. So if we cross multiply, we have this times this. That will give us 6.4 times 10 raised to the power of 6.4 times 10 raised to the power of minus 20r equals 2.068 times 10 raised to the power of minus 21. This multiplied by this will give us this. So to get r, divide both sides by this, and that will give us 6.4 times 10 raised to the power of minus 20r all over 6.4 times 10 raised to the power of minus 20 equals 2.068 times 10 raised to the power of minus 21 all over 6.4 times 10 raised to the power of minus 20. So the whole of this will cancel this, and then you're going to have r equals, dividing the right hand side will give us radius to be 0.032 meters, and that is option D. So this is our correct answer, or this is the answer to this question. Now for the next question here, they said, what is the flux, magnetic flux? That's what we have here in the three cases here. All you need to make reference to is that magnetic flux, remember we said, is equal to B dot A, alright, which is BA cos theta. Now theta was given to us in all the cases. So for case 1, alright, you can say for number 1, theta is 90 degrees. So we're going to have flux to be BA cos 90. Alright, cos 90 is 0. Alright, so 0 times the whole of this, that will give us 0. And then for number 2, flux, we have theta to be 45 degrees. So we have BA cos 45. And cos 45 is 1 over root 2. Alright, so we're going to have BA and cos 45 is 1 over root 2. So we're going to have BA times 1 over root 2. So we have BA times 1 over root 2, which is simply 1 over root 2 BA. And then number 3, we have flux. For the third case, theta is 0 degrees. So we're going to have BA cos 0. And cos 0 is 1. So 1 times this, that will give us BA. So our correct answer is 0, 1 over root 2 BA, 1 over root 2 BA, and then BA. Alright, so which one of them matches your answer? I think this is option A. So that is your answer here. So we have come to the end of this lecture. So please do well to subscribe to this channel, like, and drop a comment if you have any question or any confusion anywhere.